Okay guys, let's take a look at today's lesson. We're going to be talking about the intermediate value theorem. There are about 3 or 4 theorems that are a really big deal on the AP test, and this is one of them. The intermediate value theorem, I've seen it in free response problems. I've used in free response problems. I've seen it altered to where it could be a multiple choice problem. We really need to understand this theorem, and so I'm going to go through little bit by little bit. Also, I'm going to explain to you what it might look like on a formula quiz. You know, how might I ask you a question about intermediate value theorem on a formula quiz? So we're going to talk about those two things. We have an if and a then statement. You probably recall from geometry, the if is the criteria that needs to be true, and if all of these criteria are true, then this following thing happens. Okay, so if, let's look at the 3 criteria that have to be true. So the first is that f has to be continuous on a closed interval. We learned yesterday what continuous on a closed interval means and what we need if we were to have to prove it, what continuous on a closed interval means. The second thing that has to be true, so that's the first thing, continuous on a closed interval. The second thing is that f of a cannot equal f of b. So let me draw a picture of what something might look like. So let's say that's at a and that's at b. Alright, so it meets the first, we're just looking at the graph of a function that is continuous on the closed interval. Okay, we can look by inspection, it's continuous. F of a does not equal f of b. In other words, this y value is not exactly the same as this y value. And the third criteria is if k is between f of a and f of b. Alright, so that's kind of confusing to students, so let's break that down. F of a and f of b are y values. Right? F of a and f of b are y values. And therefore, k is a y value. K is a y value. It may be given to you, or you may have to determine what it is. If all those 3 things are true, then there exists a number c between a and b for which f of c equals k. Okay, that's a lot of words too, so let's break that down. There exists a number c. So a and b are x values, and so is c. Okay, those are x values. So there exists a number c between a and b for which basically the x value takes on that y value, is what that means. F of c, so the x value takes on the y value, which is k. Alright, so let's talk about how we would use something like that. Or first, how would I ask this on a formula quiz? There's a couple of different ways. I could say, what are the criteria to use the intermediate value theorem? And then give you 3 blanks. You would have to list the criteria, and that would, each of those would be one question. So that could be 3 questions on the intermediate value theorem, 10 points apiece. I could say, even what is the result of the intermediate value theorem, and give you a blank for that. You would need to be able to tell me this last sentence. So those are some ways that I might use test the intermediate value theorem on your formula quiz. And I've just explained how important the intermediate value theorem is, so the likelihood of you having a question about it on the formula quiz is high. Okay? Very important theorem. So, when might we use this? Let's look at this type of situation. If we have a plane that basically is on the ground and it takes off, it flies for 20 minutes. First of all, is the plane's altitude a continuous function of time? In other words, when it starts at 0, is a plane able to skip like whole pieces of the altitude? Is it able to skip over? No, right? I mean, we don't have time travel yet. It can't go out and come back in or something. It actually is going to start on the ground, and if it gets to 10,000 meters, then it certainly has gone through every single meter up to then, right? It can't jump meters. So we could say that the altitude of the plane is a continuous function of time. So it is continuous. Could we say that f of a does not equal f of b? The beginning height does not equal the end height. Yes, right? It does not equal it, so that's true. The third thing, let's say we want to prove that the plane was at 5,000 meters sometime between 0 and 20 minutes. Let's say we wanted to prove that. Let's say our k value is 5,000 meters. So is 5,000 between 0 and 10,000? Yes, so I've met all three criteria. This theorem says then there is a number c. In other words, in this example, there is a exact time where that between 0 and 20 where the function is going to take on the value of 5,000. So there is a time that the plane was at 5,000 meters. You know, whatever, I don't know, maybe 8 minutes. I mean, we would estimate. I mean, I don't know when it would be. But that is a use of the intermediate value theorem. That's how you would use it to prove something. Does that make sense? Are we okay with that? We can't really use the intermediate value theorem on here. Even if we were going to prove, like, let's say our k value was 1, and we wanted to prove that there was a k value 1 between 0 and 2. Well, there is one, but we can't use the theorem to prove it because it doesn't match the criteria. I mean, just because it doesn't match the criteria does not mean it's not true. It just means we can't use the formula, this theorem, to prove it. Okay? This theorem proves in a specific instance, and that is if these three criteria are true, then this last thing happens. Okay, so that's a general explanation. I'm going to do a problem for this. Are there any questions on the general explanation? All right, so let's go to our problem. We have one example to do. This example actually takes us through all different kinds of things. It says show whether the conditions of the intermediate value theorem hold. So we're going to have to use the theorem for the given value of k. All right, we're given a k, we're given an interval, and we're given a function. And if the values hold, if the theorem holds, then we're supposed to find c, and we're supposed to graph it. Okay, so let's work through that. So when we are showing or using a theorem, I really need you to number the things like I am. We are in training to basically have a paper, an AP paper that our reader can read. Okay, we're in training for that. We need to write it in an organized fashion. So we're going to do number 1, and that's the way I want you to do it for me. Number 1, we know, is it continuous? So we go over here. Is this function 1 over x minus 2 continuous on the interval 3 to 5? It is, isn't it? Now, there are places where it's not continuous, but it's not on that interval. Now, let's talk about that. I had a question earlier today. Do we have to prove that it's continuous on the interval? Remember the criteria we looked at yesterday? When on the AP test, when we're looking at continuity on an interval, they allow us to, basically they call it by inspection. We're saying it's continuous by inspection because we have a lot of math knowledge in our heads, right? We can sometimes just look at stuff and know whether it's continuous. They allow us to do that on the test. All right, so for number 1, we would simply say it's continuous. And we know by inspection, you don't have to write by inspection, but we know, and they allow that. So it's continuous. So we would say that it is continuous on the closed interval. So our first criteria to use the intermediate value theorem is true. Second criteria, we need to know if f of a equals f of b. Well, I don't even know what f of a and f of b are, so I'm going to go over here and I'm going to calculate them. So f of 3, if I put a 3 up here, I get 1. And f of 5, let's see, I put a 5 up there, 5 minus 2, and I get 1/3. All right, so we know that f of 3 does not equal f of 5. Okay, we know that that is not true. They're not equal, so we're good. All right, great. our next criteria is k between f of a and f of b. Now they've given us a k. All right, there will be sometimes when they don't, but they gave us a k. They told us k is 5/6. Is 5/6 between 1 and 1/3? Yes, so the third piece holds, and we're going to be able to use it. So the third piece is 5/6 is between f of 3 and f of 5. And you can write 1 and 1/3 there instead of f of 3 and f of 5. I mean, however you want to do it. So we have all three of our criteria check out. Great. That means that since they do check out, they're going to ask us to find what c is. So let's think about that for a minute. What the theorem tells us is there's at least one place in this interval, there's at least one x value that maps to the 5/6. There's at least one. Okay? So, let's take a look. So how would we find that out? How do we know what the x value was? Well, we would just substitute it in here, right? Put that y value here for the y and then find out what x is. So let's do that. So we have 5/6 equals 1 over x minus 2. A lot of ways to solve that. I kind of favor the cross multiplication technique. That's kind of my favorite, but a lot of ways you could do that. I'm going to cross multiply and get 6 equals 5x minus 10. So x is 16/5. Now, I need to talk about this in general. It is an x. And there will be times and there will be problems where you get more than one choice for x. Okay? There's a process that we have to think through this when the x becomes a c. The x becomes a c only if it's in this interval. Otherwise, it has to stay in x. Okay? I think they get really excited. They can like graduate to be c's. You know, they're x's now, but, you know, oh, this one, actually, there's one. Since the theorem held true and there's only one, we better hope that it's in there or we've done something wrong. Okay, so we look, 16/5. Oh, yeah, 16/5 is between 3 and 5. Yay, it graduates to be a c. So c is 16/5. Okay, now the last thing that they want us to do is graph. Basically, I'm just going to graph on the interval between 3 and 5. I'm not going to graph the whole thing. So we know that this equation has an asymptote at 2. I really only am concerned about 3 to 5, so I'm just going to kind of stay over here between 3 and 5. So if I substitute a 3 in here, actually I already know I get a 1. And I substitute a 5 in there, I get a 1/3. So it kind of looks like that. There's my graph between 3 and 5. And we're supposed to graph the line y equals k, or y equals 5/6. So let's do that. 5/6 is a little less than 1. And there's our graph. Okay? And what this is supposed to signify is, this is supposed to kind of show us where the c value is. And that there's just one. You know, it just basically verifies what we found. That there is a c value, there's just one of them, and it's right there. Okay, does that make sense? So that's how this problem actually takes us through all the different steps. Proving and finding c and graphing. Yes, ma'am. There could be, yes. There certainly could be two different ones. On this one there aren't, but let's say we were working with a parabola. Okay, let's say we were working with a parabola and we were going from here to here. And let's say that our k value was 0 even. The k value is 0. So in this case we would have two c values that would make that true. It just depends on the circumstance. And there could also be if we go like this, let's say this is actually a cubic. if my interval is between here and here, I'm going to get actually 2 c values, but when I solve it, I'm going to get 3 x values because this one is going to cross 0 also. So there's a lot of different combinations to watch out for. We just need to be careful that we are choosing c values that just are in this interval, the interval that you're given. Okay? Yes?
If you have a pencil and you want to draw like okay,
Mm-hmm.
the difference.
Oh, from here, you could like, I don't know, maybe do something like that. Maybe make it squiggly and say that's that's K. It's actually a line, but it's hard to tell with a pencil. I mean, there's some things that you could do to distinguish that. Okay? Or you could even like circle, just keep it straight and just like circle the K values. The C values, and the K is the line. Okay? Other questions? All right.